Weight shift controls 7-3 takeoff and departure climbs. In the critical phase of a short-field takeoff, precision is key. Once VX speed is reached, smoothly apply forward pressure on the control bar for an attitude matching the VX airspeed. After lifting off, maintain a wings level climb at VX until you've cleared obstacles. Then, slightly lower the pitch and transition to a climb at VY speed until reaching a safe altitude. Caution: avoid premature lift-off or overly steep climbs, as these may result in undesired descents or obstacle encounters. Ensure a smooth takeoff by planning for runway length, considering obstacles, and optimizing weight and trim. Prioritize efficient runway use, attend to atmospheric conditions, and maintain situational awareness without fixating on airspeed during the initial climb for a safe departure. Taking off from soft or rough fields demands a specialized approach to overcome drag caused by various surfaces. The weight shift control's unique design, especially the high wing and the potential for front wheel issues, requires careful consideration. When facing soft surfaces like mud or sand, it's crucial to keep continuous motion with ample power to avoid getting bogged down. Align the aircraft, apply power smoothly, and swiftly move the control bar full forward to establish a positive angle of attack. Maintain a nose-high attitude to progressively transfer weight from the wheels to the wings, reducing drag. The aircraft virtually lifts off on its own if this attitude is sustained, using ground effect to become airborne at a slower airspeed. After lift-off, gently lower the nose just above the surface to benefit from ground effect, accelerating to VY or VX if obstacles are present. Avoid climbing prematurely to prevent settling back onto the surface. Stay in ground effect until at least VX is reached, showcasing a fine control touch to avoid over-controlling. Swiftly getting off the ground and flying in ground effect is the objective. Common takeoff errors include inadequate tire maintenance, low pressure, lax forward control, weak directional control, steep climbs, sudden pitch changes, premature lift-offs, and attempting to climb too early. A rejected takeoff may be necessary due to various reasons, such as power plant issues, items dislodging, inadequate acceleration, runway incursion, or air traffic conflicts. If the aircraft is not airborne at the predetermined point along the runway, the pilot should take immediate action to discontinue the takeoff. This involves reducing power, applying maximum braking, and maintaining directional control. In the event of a rejected takeoff, the power should be reduced to idle or the engine shut off, and maximum braking applied while ensuring directional control. If shutting down the engine is necessary, follow the manufacturer's emergency procedures. Urgency characterizes power loss or engine failure occurrences after lift-off, requiring rapid decision-making. In the case of an engine failure on initial climb out, the pilot's priority is to maintain aircraft control. Lowering the pitch attitude is crucial to prevent a stall. Climbing to a safe altitude and establishing a controlled glide toward a suitable landing area is recommended. Noise abatement procedures at airports aim to minimize aircraft noise over nearby areas, and pilots should be familiar with and comply with these procedures. Normal takeoffs involve a straight path down the runway with rotation at the proper airspeed and initial climb at a safe airspeed. Crosswind takeoffs are similar to normal takeoffs but require keeping the wings straight during acceleration. Short field takeoffs ensure sufficient runway is available, utilizing best angle of climb speed until obstacles are cleared. Rough or soft field takeoffs involve keeping weight off the nose wheel, lifting off into ground effect to gain speed quickly. Precautions, such as climbing at faster airspeeds and lower pitch angles, should be taken for engine failure or rejected landing scenarios.